This conference will now be recorded.
Hello, everybody. Thanks for joining us today for the Satellite Book Club Seminar Series. This is session number 9. Hope everybody's doing well. We'll be hearing about a Florida Keys cloud line. Goes our applications for warning ops and IDSS from William Churchill at the Key West Weather Forecast Office. Just a few reminders before we get started that we'll be recording this and there will be an opportunity for Q&A after the presentation. Feel free to type your question in the chat or we'll hopefully have some time to address it after William's done presenting. If you're interested in presenting, particularly if you're at a field office, feel free to get in touch with us, or if you need training related to satellite products, Brian Mata and the team at the Office of the Chief Learning Officer can certainly help you with that. There's plenty of materials that are out there from Oklo and its partners. Want to just thank the Tower S team, David Blutis and Lee Byerly, for supporting this, as well as Oklo, GOES-R, and the JPSS programs for supporting this and really providing an opportunity to help the field understand and realize new applications for satellite data. We really appreciate you joining us today. And if you're interested in the future of weather observations from satellite, GeoXO, that's the new program, the follow-on for GOES-R perhaps, geostationary and extended orbits. There's going to be a workshop next week. You don't have to attend the whole thing, but if you're interested in one or more of those sessions, feel free to sign up. There's a link there, and it's a great opportunity to explain what your requirements are, what your needs are, how you see the field of operational meteorology evolving in the next 10, 20, or 30 years, and how satellite can really help with that. I think it's going to be a really great discussion. We hope to have a lot of good field representation, also representation from our partners, international and domestic. So please consider registering for that. And again, that's next week, Monday through Friday, predominantly in the afternoon if you are on the East Coast. So without further ado, I'd like to introduce William, who's a forecaster at the Weather Forecast Office in Key West, Florida. He's the remote sensing focal point for the Keys. I know I follow his Twitter feed. He's got a lot of good color enhancements, a lot of good applications for satellite data. And he is particularly interested in advancing remote sensing applications and high resolution numerical weather prediction. So thanks for being with us today, William Churchill, and look forward to your presentation.
Alrighty, thank you, Jordan, for that introduction, and thanks everybody for tuning in today. Appreciate you taking time out of your day to be here. So, just going to go through this presentation here about what is known as the Florida Keys cloud line, as we refer to it here at the Weather Forecast Office, and some more specific GOES-R applications with regards to that. So just getting started, let's see here, just to talk briefly about what the cloud line is in general. It's really this line of deep cumulus convection that's driven by the differential heating differences between the Florida Keys island chain and the surrounding shallow hot waters. And I do mean hot because we get pretty easily here in the bay waters into the lower 90s this time of year here in the warm season. And how the cloud line really manifests is from the lower tropospheric wind profile. So you really need a mean wind from the east-northeast to get what we call the regular cloud line setup, or from the west-southwest to get what we refer to as a reverse cloud line, simply because it's not nearly as common, since our prevailing wind direction is often from the east, way down here in the, we get into the easterlies of the tropics, basically. So, but of course, the wind isn't the only important thing. You need a thermodynamic profile that's going to support cumulus production in general. And research has found that if you have a dew point depression of greater than 10 degrees Celsius within that critical layer from about 925 millibars up to as high as 700 millibars, it's going to be pretty unfavorable due to dry air entrainment from the surrounding air. So basically you get this equivalent potential temperature buildup that's most pronounced over the lower Keys. You can see from this high resolution Landsat image here that most of the land concentration is in the lower keys, the sprawling lower keys. And you get that theta E really maximized right over Big Pine Key, which is the easternmost key of the lower keys there, the largest one, which makes sense, of course, where you're going to get the most theta E. So the cloud line really has associated thunderstorm hazards that include waterspouts. I'm sure you've heard about the waterspouts that occur in the Florida Keys, and this is really the main driver of waterspout formation, especially in the wet season. And of course, other thunderstorm hazards, typical, which are lightning and wind downbursts, flooding from training cells, etc. And while this is not really well modeled from high resolution models like the HRRR or even the other CAMs, they're really not high enough resolution to model this well. It is surprisingly predictable. That's why we've come up with this, saying of calling it the cloud line and really focusing on these two prevailing directions, because if you've got that direction prevailing and you've got a suitable thermodynamic profile, then you can really hang your hat on this, despite it not being modeled very well. So here's just to show, got the normal cloud line from the east-northeast and the reverse cloud line from the west-southwest. And you will get this along the entire island chain. It's just most pronounced in the lower keys. We'll go through an example. But here's a zoom in just so you can get a little higher resolution view of the keys here, and that's Big Pine Key. And of course, the most urbanized, you can tell just from this Landsat image, but not the westernmost key there, Key West. There are some more keys to our west of Key West, but that's as far as you can go on the highway. So we're kind of the westernmost key to that extent. So getting into the waterspout hazards a little bit more real quick, you can see from the observed waterspouts here from 2006 to 2016, they can pretty much happen anywhere along the island chain. You can tell though there's a little bit higher density of reports in the lower keys, particularly surrounding Key West. And waterspouts are really among the greatest weather hazard for mariners. Thankfully, they're easy to see and typically easily avoided. We don't get too many injuries with them. Make a great effort to tell people to stay away when you see one. Now with the cloud line, these waterspouts are not associated with a mesocyclone, or in other words, they're non-supercellular. So you can compare them to land spouts that happen over land. They often occur in the gaps between the islands where you get surface vorticity maximized. They can happen with little to no warning, often associated with otherwise benign showers. And you don't really even need a shower necessarily, just the very beginning stages of one to get one of these to develop. And so identifying the ideal environment is really crucial beforehand to anticipate the development, but it is rather difficult just because we have a very similar profile day to day during the wet season down here. So you really got to focus on that mean wind and that lower tropospheric profile. And of course, visible satellite, while the event is actually going on once the cloud line is starting to manifest, really proves to be more useful than WSR88D data in monitoring the development of the cloud line, since a lot of times you can get these developing really right at the onset of showers. So the satellite ends up being very useful. Before I get into some of the satellite imagery, just wanted to show here a couple images of the waterspouts. Couldn't go without showing you those. So here's a couple sort of iconic pictures, one with our ray dome in it and the other from the airport when the office used to be at the airport, looking north towards the waterspout there. And just wanted to show a couple of the other hazards. So on the left there, we've got a small intense cell, on the right there, with the boat, you can see we had a small intense cell that caused a 60-knot downburst and caused this ship to severely list. Thankfully, there was only one minor injury on that, and the boat was able to regain itself. On the left there, you have a nearly 5 inches of rain in a 90-minute period in Newtown. This is at our MIC Chip Casper's house in a part of Key West. And so almost 5 inches in 90 minutes from a really significant cloud line due to colliding boundaries with an otherwise fairly benign cloud line. But that was on a 20% chance of rain day, which turned into a 50 to 100 year, basically recurrence interval event. So pretty dramatic, and you really never know down here when things are going to get that crazy that quickly due to the small nature of the mesoscale effects. So getting into some of the actual satellite stuff, really the most useful thing down here is visible imagery to track the cloud line. And that's just because of the amazing high resolution that red visible band provides, as well as the relatively low latency that we've seen with the introduction of GOES-R. So, we're watching in real time it develop, and if you have 1 minute imagery, even better, of course, quintuple that temporal resolution. But of course, long wave infrared, channel 13, the clean long wave, as well as GLM with the flash extent density product for lightning jumps. Those are both crucial for just tracking updraft strength in general. They're a very good supplement to radar data. And GLM really has a special role as well down here for airport weather warnings, because we have the kind of iconic jetwayless airport in Key West. If you've ever been here, you step off and you're going down the stairs immediately. You don't get a nice jetway into the terminal. So we have a tried and true method with WSR88D in terms of getting 40 dBz up to a particular height just above the -10 degrees Celsius, basically. But what I've found is that flash extent density, what we found at the office, that product can really help supplement it. And sometimes with it being updating every minute, you can actually get it before the radar data suggests that your updraft is getting that high. So if you get a cloud flash, obviously that's going to many times precede a CG strike. So that is very useful for issuing airport weather warnings, in particular for our airport that is particularly vulnerable. And then of course you can extrapolate all this to IDSS implications as well, as some of the more recent ones being the US-1 checkpoint that we had at the mainland when we started getting shutdowns from the pandemic. They had tents out there and they were operating 24/7, so they needed to be notified of any impending serious weather. And now currently monitoring conditions for the vulnerable COVID-19 test sites, which I'm sure many offices are currently doing across the nation. So just a picture of the Key West Airport from above, and as well as when you're coming in, if you've visited, I'm sure you've seen that iconic site of Welcome to the Conch Republic. So just wanted to show just one example. This was just a few days ago, actually, and we've kind of been in this atypical westerly surface lower tropospheric wind environment. We've just recently flipped around here to the east again, but just a few days ago we had this development. So you can really see the cloud line take shape coming off the lower keys there. And you can see coming off of Big Pine Key, just north of the 7 Mile Bridge there, the gap between Vaca Key and Big Pine Key where the cumulus really gets going. But let me switch to a secondary loop here, which will show where we issued a special marine warning. And this is going to show you where the waterspouts occurred. So really before you even get any significant development of the cumulus, and then again a second time with slightly more developed. But by the end there, when you're getting the true thunderstorms starting to develop out of it, by that time we weren't getting even waterspout reports anymore. So it's often very early on, and this visible imagery really helps us get ahead of that and anticipate it as soon as we get that report. And then here's that overlaid with some infrared imagery as well, just to give a little bit more context there, because you can see at the end, boom, now you're starting to get some of the colder cloud tops, the colder than -20°C filtering through. But for both of those warnings, both of those waterspout warnings, where we had multiple waterspouts develop, albeit weak, you don't see those signatures of a strong thunderstorm associated with it. So pretty typical non-supercellular waterspouts. And then just lastly, wanted to talk about some other potential GOES-R applications. I work a lot of midnight shifts, so I'm actually not on shift a lot of times during the day. But I think there's 2 daytime RGBs that could be particularly helpful, that can kind of help enhance just the single visible imagery. You have the day snow fog RGB and then the day convection RGB, and both of these really emphasize the presence of ice particles. I think the more complex day convection RGB in particular could show some promise. Once you get those yellow colors, you're showing the presence of particularly small ice crystals, which are thought to be indicative of stronger updrafts. So that has some interesting implications, particularly for strengthening convection, a little bit less so with the waterspout side of things. And of course, just 1 minute imagery. I think all of us can never get enough of that. And just that detail, that minute to minute detail in the visible, very, very useful, no doubt, in the monitoring of the cloud line. And then I just wanted to briefly talk about, I mentioned, I work a lot of midnight shifts. We also get this phenomenon of cloud line reactivation. So you get that lingering theta E overnight that didn't get worked off from the cloud line during the day. We often see, as you can see here, some of those earlier pixels are the original cloud line during the day. And then towards the ends of the loop right here, you can see the flare up, the lightning jumps happening over the island chain, and that's in the middle of the night. So we often get these colliding land breezes from Cuba and the Florida mainland overnight that reignite this cloud line, and we kind of refer to it as cloud line reactivation here. So always makes for very interesting midnight shifts, even when you're not necessarily expecting anything. So, and of course the satellite products are helpful for that. Visible, not so much, but the other ones are. So had to kind of finish here with a little multiple waterspout image that occurred here in the Keys, and there's my email and Twitter handle if you want to follow me for satellite imagery. But with that, we can take questions and do some discussion. Thanks.
All right, thank you so much, William. That was excellent. So at this time, we will be opening up to questions and answers and a short discussion here. And before we do that, though, I did just share a link to a short survey to share your feedback. If you'd like to do that, I submitted that in the chat room. We will also be sharing this feedback survey out in the follow-up email as well, if you'd like to do it then. So again, if you'd like to ask a question, we do encourage you to ask it in the chat room here. If you would like to ask a question verbally, you can certainly do so, and you can just indicate that in the chat room, and we'll make sure we can unmute you there. So does anyone have any questions for William? Okay. William, I do have a question for you here. So which weather-related hazard related to the cloud line is most difficult to forecast, and why?
Yeah, I think obviously the water spouts are difficult, but you know, if we know the wind regime and we're kind of anticipating them for that day already, you know, we actually have a statistical index that was developed by our SU, Andy Devanis here as well, that really kind of keys us in on whether or not it's going to be a particularly active waterspout day. So we tend to do fairly well with those actually in anticipating them. So I think one of the harder things is you never know exactly how everything's going to manifest. So, you know, like the example of at our MIC Chip's house where he had almost 5 inches of rain in that 90-minute period, I think that's really the hardest hazard to get ahead of, you know, whether or not that training heavy rainfall is going to happen. And, you know, it takes a lot of rain here to cause flooding issues, but 5 inches in 90 minutes will do it, particularly over Key West where we're urbanized. So I'd say that's the hardest.
Okay. Haven't seen anything yet. Don't be shy, everyone. I do actually, so I have another question for you here. How do the hazards change when the orientation of the cloud line is atypical?
Yeah, that's interesting because, you know, we kind of have the typical cloud line and then the reverse. So, you know, depending on which direction it is, that's going to have different impacts. I think the regular cloud line orientation tends to favor Key West getting hit harder with potential hazards. But I would say what makes it really difficult when it's atypical is it never truly fits just one or the other pattern. You know, like it kind of assumes a synoptically benign environment. So if there's anything else going on synoptically, or even just other mesoscale interactions going on, so if we're getting, you know, outflow boundaries coming from the straits or from the bayside, that's just going to throw a wrench into things. So I think that's when the atypicalness kind of sets up and makes things more difficult, which is most of the time. It's rarely very straightforward, like presented here.
Mm-hmm. Okay. So we do have a couple questions here coming in. First one, how does Key West make use of JPSS?
It's a good question. I actually definitely always take a look at it at night myself. You know, the day-night band pass in particular, I think is always fascinating to look at. Of course, with the delay in the imagery, I would say it's not particularly useful operationally, unfortunately. But you know, it's always a nice thing in hindsight to look at. But yeah, unfortunately, because of the delays, we're definitely making use of the GOES data more often.
Okay. Another question here. Would you be willing to share the statistical index that your SU developed?
Yeah, definitely. Looks like, yeah, actually Chip just posted it there and there in the chat, so you can check that out.
Okay, very good. Does Key West use ProbSevere?
I've looked at it a little bit. I don't think it's, at least in my experience, and again, I'm not on as many day shifts, so I'd actually be interested in looking into that more, particularly when we have the robust convection from the cloud line itself. I know there are some people in our office that definitely take a look at it, but more times than not, I've found it's not as useful down here compared to like my previous office in Memphis, for example. It just doesn't, a lot of things aren't as tuned as well for the keys down here just because our environment's so different. So.
Okay. How are the GOES-R products used for IDSS? Does it need any particular systems to show GOES-R images?
They're mostly just used internally for IDSS, so I'm not sure I understand. You know, we're using them basically in the same way we're using them for our warning operations decisions. We don't usually need to share the imagery with the partner in general.
Okay. Does anyone else have any other questions? Oh, we got a couple coming in. Did you find that that you can get a meso when you need one of the mesoscale?
I know we've definitely requested them at times. Usually, it's of course it's dependent mostly on if there's a lot of weather going on elsewhere, but obviously when there's tropical systems coming, we always have it, so that's nice. But in terms of a cloud line, we're kind of dependent on there not being severe weather elsewhere in the nation for us to be able to request it. So obviously if the radar goes down, that'll give us priority and can definitely get one no problem in that case.
Right.
But most of the time it's dependent on that.
What improvements and or changes would you like to see from GLM data in AWIPS?
I mean, I'd personally like to be getting it for the full disk because I think we're still only getting it for the CONUS, which is a little disappointing to me. But in terms of for locally at the office, I'd also like to see, you know, the full suite of products coming down because I believe we're still only getting the flash extent density. I know in Memphis we were a test office for the couple other products, the power and the aerial extent. So definitely as much of that as we can get would be great.
Does Key West make use of any level 2 products like stability indices, fog product? And there was also our DMWs, drive motion winds.
I've looked at the drive motion winds a good bit. Most of the other products, the fog and stuff, not as useful down here.
All right. Last call. Oh, got a couple more coming in. How do you use the DMWs?
Really just to compare to our sounding, particularly when we're between soundings, if we're, you know, trying to get a look at how the winds are changing at particular levels. So specifically that lower tropospheric, those lower tropospheric winds, if we can get DMWs that pertain to those and see how they're changing between soundings, that's when it's very useful.
Okay. And I see we have a comment from Chip. Thank you, Chip. And we have another question. Can you talk about your experience using the mesos in the context of when radar is down?
Yeah, I mean, in those cases, obviously just having the visible imagery every minute just helps in general, whether the radar is down or not, just in terms of monitoring the cloud line. But I would say the biggest benefit when the radar is down is getting the minute data for the long wave infrared in particular, because you really want something that's going to show you, you know, a strengthening updraft that the radars wouldn't otherwise show you during that time. But thankfully, you know, we still have Miami, so we're able to compare it to that. So you've always got, you know, some redundancy there, even with the radar data. But just having those minute updates in the long wave infrared can tell you when you're getting a you know, rapidly developing updraft, which thankfully GLM does every minute, even without the meso. So it's just great having all that different context, putting it all together.
Yeah. What does Key West use for monitoring sea surface temps?
We have some sea surface temperature sensors like in Key West Harbor, and we have quite a few in the Florida Bay. So we have those direct measurements, but we also get the sea surface temperature updates in AWIPS, which I believe is under the satellite products. It's like a composite image that we get through there in AWIPS. I think most offices get that. I'm not sure if it's just us. Yeah, remotely sense the yep, the composite one is.
Okay. All right. Anything else? This has been a great discussion. Last call. All right. I think with that, well, thank you again, William. That was terrific, and we really appreciate you taking the time to present for us today. This time, give me 1 second here. Just trying to take the screen back. So looking ahead to next week, please join us next Thursday, July 23rd. We will be having Carl Dierking, Satellite Liaison and Developer for the Geographic Information Network of Alaska, or GINA, at the University of Alaska Fairbanks, and he will be presenting on the JPSS Aviation Initiative, as well as satellite products for aviation users that help to fill large observation gaps in Alaska. And please stay tuned for an email from us with the TowerS team. We'll be sending that invite email out on Monday. And just a quick note on that. So next week's session will be at 3:30 p.m. Eastern time, change from our normal noon time here, so it will not conflict with the GeoXO weather workshop. And then if you need any assistance with AWIPS data flow or configuration of satellite products, please feel free to reach out to us at any time on the TowerS team, either Lee Byerly or myself, David Blutis. We're happy to help. And if you're in the NWS chat, you can always reach out to us there on the TowerS chat room. We'll be happy to answer and field any questions you may have there. And I'll just conclude here by just putting up the information for the GeoXO weather workshop once again. And thank you all so much for attending today. We really appreciate it. Have a great rest of your day, and we'll hope to see you next week. Thank you.